welcome our viewers. Yesterday we had a beautiful moment revising on indices, and here we are again as we come to the end of the topic or revision of the topic. We shall conclude today, and fortunately today we are on live on our Facebook. Thank you because of our followers, and you please very soon we shall be in our YouTube. You can be able to subscribe, you can like, and we can be able to help one another together. And like we said yesterday, this is a period, this is a moment that nobody could wish to find himself in such a scenario or in such a situation, but we thank God because of everything. Everything happens for a reason, and in His Word, it is reminding us that everything that happens for a reason, and that is a good reason. So today we are here, and then before we are back on some examples on indices, I would like us to remind ourselves on some of the few rules that we apply on solving questions on indices. That's the rules that we apply, because it's all about application of rules. What are these rules that we apply in solving indices or questions concerning indices? Now, one of the first rules that we apply is the multiplication rule. I know many of us will know this one, but we're going to remind ourselves about multiplication rule. This is where we say that, for example, if A is multiplying by A power 1 is multiplying by A power 2, as much as the bases are the same, we just need to equate to just write the base, then we add the indices or the powers. Thereby, this one should give us A power 3. We can prove this one by because initially in our O levels we found that if number is raised to a power, it means it's a number multiplying by itself the number of times equal to the power. For example, if it is A power 2, this one means it is A multiplying by A. And therefore, for instance, if you have A power 2 multiplying by A power 3, this one means it is A multiplying by A into bracket multiplying by A multiplying by A 3 times. This means it is A multiplying by when you open the bracket, and this one will give us A power 5, or A multiplying by 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 itself 5 times. And therefore, if we apply this law, we can see very clearly if you multiply the number by itself 5 times, we get A power 5, which is the same as adding the powers 2 and the power of 3. If we add these powers, we get A power 5. So simply, when we have to multiply numbers or numbers with a common base, we just need to add the powers and write the base as it is. Then we have another law which we shall find ourselves applying most of the times, and that is the quotient law or rule, quotient rule, that is concerning division. And this is where we say that every number, if they have a common base, if a number is divided by another number, provided that they have a common base, we just need to subtract powers. We can prove this one. For instance, if we have A power 3 divided by A power 2, if you have A power 3 divided by A power 2, we are saying simply we just need to write A, then we have 3 minus 2, which is 3, which are the power 1. This one we can try to prove it manually. We can call this one digital because it's simpler. It makes the question more simpler. If you have A power 3, we can write it as multiplying by A multiplying by A, and all of these we can divide by A multiplying by 2 by A, sorry. And this one, if we simplify this one, it will give us A power 1, which is the same as A power 1. Therefore, if a number is divided by another number, provided that the bases are the same, we just need to subtract the numbers. We subtract the powers and write the base as it is. This one takes us to another rule which we apply in indices, whereby we say a raised, whereby we say 1 over a raised to power 2, we can raised to power b, we can write it as a power negative b. How do we arrive to this one? Now, for example, if we have in our initial equation where we had a power 3 divided by a power 2, we can write this one the other way around, such that we have a power 2 divided by a power 3. Manually, this one will give us a multiplied by a divided by a multiplied by a multiplied by a. When we simplify this one, we get 1 over a power 1. We can have another number, that is a power 2 divided by a power 4. This one will give us a multiplied by a divided by a multiplied by a multiplied by a multiplied by a, and this one will give us 1 over a multiplied by a, which is the same as 1 over a power 2. Now this one, if we apply the quotient rule, for instance, in such a equation here, whereby we have a power 2 divided by a power 4, we shall get that because the bases are the same, we just need to subtract the powers, and this one will give us a 2 minus 4, which will give us a raised to power 2. Therefore, if this one is equal to this one, and it's equal to this one, therefore it means this number is equal to this one, such that 1 over a power 2 is the same as a power negative 2, equals to a power negative 2. That's the quotient rule. Then lastly, we have another rule that we mostly apply when we shall find it when we come to use of logarithm in indices, as we shall see. Maybe that's where we shall move after indices. That is application of logarithm in solving problems. Now, that's another rule where we say that when a number that has been raised by another power, if you raise it to another power, you just need to multiply the powers. Simply what we mean by it's a, if a is raised to power b, then you happen to raise this number to another power m. Simply this, we can write simply this one as a power b m. You just need to multiply the powers. You just need to multiply the powers. You need to multiply the powers. Now, having gone over some of the rules that we usually apply, or basically the rules that we apply in solving questions concerning indices, because in a KCSE setup, mostly what you'll find, you'll be applying these laws in solving a problem. You'll be solving for problems using the laws of logarithm. And as we saw yesterday, we were solving some of the few examples that were in a problem form, and we were trying to find a solution by using the laws of logarithm. Remember, we said again, Jesus is the answer. In mathematics, we find a solution. So whenever we are given a problem, we try to simplify the problem to get we simplify the problem to get a solution. The good thing with the mathematics is that you create your own problem and you solve the problem, or the problem is created by someone else and then you are there to solve the problem, but not finding the answer, but solving the problem. There is much similarity between mathematics and politics. You find, like in Western, a problem was created by someone else, and now people are struggling there finding a solution to the problem. So in mathematics, that is what happens. A problem is created, we solve a problem. But it helps us even understand. The good thing with the mathematics, and I will encourage us to try and understand more of these problems. When you're used to solving mathematical problems, then understanding other subject, it becomes more easy. Your brain is able to accommodate, it expands. You are able to solve other problems. That is, other problems isn't even in other subjects like chemistry, physics, and even life problems, because life is a puzzle. It's full of problems which you usually find solutions each and every day. Now, it's better you get used to finding solutions to problems, because not only in mathematics, even in outside the academic, outside the numbers, outside the numerical numbers that we keep on doing and algebraic expressions, we shall find ourselves solving life problems, and we shall be required to apply the skill that we've learned in solving problems. Now, I want us to do some few examples on indices as we come to end of it. Then in our next lesson, that is on Wednesday, we shall be able to see whether we can be able to do some few questions on logarithm, because this is a one topic. Logarithm and indices, they are one topic. They relate so much with they are just one topic. They relate so much. So in our next example, we can be given such a problem where we are told to solve for x. Solve for x in the equation, and the equation we are given as that 2 raised to power x minus 3. Then we are required to divide it by x, 8 raised to x minus 4. Sorry, this one is equals to 64 divided by 2 raised to power x. This is someone who has created a problem, and they need to find a solution to this problem. And remember, as I will keep repeating and saying again, we don't find answers. Someone from class 5, 6, 7, you have been finding value of x, and each and every time you find different value of x. So x has no definite answer. It has no definite specific answer. What we do, we solve for the value of x. So we try to find a solution, and the solving is finding a solution. That's why we are told to solve. We are not told to find the answer. Jesus is the only answer, and that's why we need to remind ourselves each and every day as we find even problems in our lives. Let us know that Jesus has the key. He is the answer of everything. So in our case here, we have two numbers. Remember, we said yesterday that whenever we are provided with numbers, the first thing we try to do is to write the numbers into a common base, such that we are able to apply the law of logarithm, or not logarithm, but indices, whereby we can either add the powers, we can subtract the powers from one another, provided that the numbers are written into a common base. In our case here, we can write these numbers into a common base of 2. For example, that 2, we can write it as 2 raised to power 5. In bracket, we have x minus 3 divided by 2. 8, we can write it as 2 raised to power 3. Then into bracket, we have x minus 4, which is equal to 2 raised to power 6. Then divided by 2 raised to power x. The numbers are already into a common, they are written in form of a common base. Therefore, we can be able to, we can equate the powers. The powers, we have 5x minus 5 multiplied by 3, which is 15. Then all these one, the bases are the same, so we subtract. 3 into x, it is 3x. Then minus 3 into 4 is equals to 12, equals to 6 minus x. From here we have 5x minus 15 minus 3x. The catch is here now. Whenever you see in mathematics, you see a bracket, be careful of negatives and the positive. Remember what you are saying in primary about the negative multiplying by negative, positive multiplying by negative. Then you came to integers, you did a lot of this. So whenever you see a question in mathematics, whenever you see a bracket in mathematics, simply take care of negatives. So in this case, we have negative here. So negative multiplying by positive 3, we get negative 3x. But the negative multiplying by positive negative 12, we get positive 12, which is equals to x minus x. This one will give us 5x. When you group the right terms, we have 5x minus 3x minus 15 plus 12 is equal to 6 minus x. From the right hand side, we have, when we subtract this one, we shall get 2x. This one is negative 15 plus 12, which is equals to negative 3, is equal to x minus, 6 minus x. We can group the right terms further. We take this the other side, and then we take it to the other side. That is how you are shown in primary school. But there is another way of solving it, such that we have 2x. If we want to eliminate 3, we can add 3. We add 3 the other side. If this other side we want to eliminate x, we just add x and add x the other side. But let us use the shortcut. We have 2x. We take x the other side, it was negative, so it becomes positive. This one will give us 3x equals to, we take 3 the other side. It was 6, so it is 6 plus 3, which is equals to 9. Then you have 3x is equals to 9. Divide by 3, we divide by 3, and x is equals to 3. X is equals to 3. This is a problem solved. So in our case, x, the value of x is equals to 3. That is using, you can see from our example here, we have used the quotient rule or the division rule, whereby we subtract the powers when the bases are equal. That is application of laws of indices in solving problems, mathematical problems. So we shall have some 2 more examples, and yeah, the next example is find the value of x. Find the value of x in the following equation. Find the value of x in the following equation, and the equation is 49 raised to power x plus 1 plus 7 raised to power 2x. This one is equals to 350. We are trying to solve for the value of x in such an equation. And remember, we said we try to write the numbers into a common base. If you see 49, we can write it into a common base of 7. We can write it as 7 squared. But 350 is not a multiple of 7. So we cannot be able to write it into a common base of 7. But basically, we say when we see a question concerning indices, the first thing is to try to write numbers into a common base. So we can leave this one and try to write the numbers that are applicable. The numbers that we can be able to write into a common base, we write them into a common base. We leave the numbers that cannot be able to, that you cannot be able to write into a common base. Whenever you see a problem, don't just try to find the end of the solution before you. You go step by step, slowly by slowly, it unfolds itself and it will give you direction. Don't just solve the question in your mind. You just look at the question and you want to find the answer. You want to write the numbers into their bases. You want to solve the problem and get the solution by just looking at the question. Just write something, scribble something, write something, write the basis. The question will solve itself. Now, in our case here, we have 49, which is raised to power x. We are saying this one, we can write it into a common base of 7, and we shall have 7 raised to power 2 in bracket x plus 1, then plus 7 raised to power 2x, which is equals to 350. Now we can open this one. You remember the rule of powers, whereby we multiply the power by another power. So we can have this. We can write this one as 7 raised to power 2x plus 2. And remember this number, which is 7 raised to power 2x plus 2. We can also write it as 7 raised to power 2x multiplied by 7 raised to power 2. So this one we can write it as 7 raised to power 2. Therefore, you can see from this one, if you just write it to a common base of 7, then you add the powers, 2x plus 2, it will give you back, it will take you back to this point. Therefore, this one, it's very okay. It's very okay if we write this one as 7 raised to power 2x multiplied by 7 raised to power 2 plus 7 raised to the power 2x is equals to 350. Then from here we can remove a common number. That's the common number from these two numbers outside the bracket, whereby we shall have 7 raised to the power 2x into 7 raised to power 2 is 49 plus 1, which is equals to 350. This one is equals to 7 2x multiplied by 50 equals to 350, and then from here we can solve. You can divide here by 50. We divide by 50, we get this one is equals to 7, such that we have 7 raised to power 2x is equals to 7 raised to power 1, which is equals to, we can equate the powers because the bases are the same. We get 2x is equals to 1, and the value of x in this case is equals to 1 over 2. Finally, as we come to the end, because I've seen we are short of power, as you can see, you cannot be able to see me very clearly. I will do just one very small example, the last example. Then we come to the end of the lesson today, and that is I want us to apply one law that we never mentioned as we were trying to revise the laws of indices, and we can solve this one. 3 raised to power 2x plus 1 multiplied by 9 raised to power x minus 3 is equals to 1. As you can see, the numbers, we can be able to write the numbers into a common base, and whenever you see 1, remember we said in any number raised to power 0 is equals to 1. 100 raised to power 0 is 1. 1000 raised to power 0 is 1. A raised to power 0 is equals to 1. Therefore, we can write this number as 3 raised to power 2x plus 1 multiplied by 3. 9 we can write it as 3 squared into x minus 3 is equals to 3 power 0. Because any number raised to 0 is equals to 1. Therefore, 1 can be equal to 3 raised to power 0. And this one will give us numbers that are in common base. Therefore, we can be able to equate the powers, and we can get 2x plus 1 in bracket plus 2x minus 6 in bracket is equals to 0. This one will give us 2x plus 1 plus 2x minus 6 is equals to 0. We can group the right terms here. We have 4x plus 1 minus 6 is equals to 0. And this one we can have 4x minus 5 is equals to 0. We take 5 the other side. We have 4x is equals to 5. We divide by 4, we divide by 4, and the value of x is equals to 5 and 4. 5 over 4. That's 5 over 4. I'm sorry we've gone short of power, but we appreciate your time, the time we've been together. We have been able to help one another in solving problems on indices, and moving forward we shall be able to help one another more as we even find more avenues that shall help us to be of benefit to one another, as we even try to help one another at this time that we need one another of the more. So I would encourage us, we as a society also, as we are passing through this period, may we find an art to help one another, wash your hands, sanitize, take care of yourself, and especially today now the government has opened and locked some limitations, has uplifted some limitations. So just take care of yourself. Life is about yourself, not about your brother, not about the government. It's about you. Just take care of yourself, and then play your role, play your part, and God will take care of the other part. You play His role. So take care of yourself. Go to church, wash your hands, eat well, and God is there for all of us. So good night, and I wish you well as you even continue preparing yourself for your exams.